Hello everyone, welcome to the Electronics Troubleshooting lecture series. My name is Neha, and in this lecture I'm going to cover troubleshooting issues in series and parallel circuits. So let's get started. Troubleshooting opens and shorts in series circuits. We'll first start with the effect of open in a series circuit. An open circuit is a circuit with a break in the current path. When a series circuit is open, the current is zero in all parts of the circuit. So, and in that case, the resistance of an open circuit is extremely high because the air between the open points is very good, is very good insulator. So, and that's why we can have like billions of ohms of resistance, or you can say you will have infinite resistance in the circuit if there is any open circuit is there. And when a series circuit is open, then the applied voltage appears across that open terminals. So we're going to see that through the circuit. As you can see here, we have these two circuits. And the first circuit shows the normal operation where this voltage source is connected to the resistance. A 5 ohm resistance is there, 10 volts voltage source, and a 2 amps of current is flowing in this simple series circuit. Whereas when you have open in this circuit, so you can see this is an open in the circuit, then definitely there will be no current because there is no path for current to complete. So there will be no return path, and that's why zero current, and resistance in this case is going to be infinite because this is going to create an open space, and it will act as a good insulator, and therefore that will create your infinite resistance. So an open circuit has zero current flow. And let's see next. Next is a short circuit in a series circuit. Uh, this is the same circuit which you saw previously, and in this circuit we have basically used a wire and connected it to these two terminals. So if you think of this wire, then in this wire, when it is connected to this circuit, this wire will have zero resistance, okay? And this particular branch has some resistance which has some value, and this is going to be higher than the resistance flowing resistance in this particular wire. So what will happen, you know that the nature of the current is that it try to follows a path of low resistance. So the current will try to follow from this route flowing from this wire, which is shorted, which is used to basically short these two terminals. So current will flow through this, and that current is going to be the heavy current because the resistance is zero. And that's why you see that as resistance approaches to zero, current approaches to infinite. They have the inverse relationship. And so a short circuit has excessive current flow. So this was your short circuit in a series circuit. Now we are going to see the effect of open in a series circuit with multiple resistances. As you can see, we have three resistances connected in this particular circuit, where VT is the supply voltage of 40 volts, and these three resistance values are given. R1 is 25, R2 is 10 ohm, and R3 is 5 ohm. And you see here that there is a open circuit condition. So if you see a open circuit condition in a series circuit, the first thing you know is that you should know is that the current is going to be zero in the circuit. So that's what you see here. The current is zero. And if the current is zero, then the voltage across each resistance is going to be 0 volts. Why? Because by the formula V is equals to IR. If I is 0 multiplied by whatever the resistance is, that will create 0 volts. So that's why you see 0 volts. And the third thing you should remember is that this open, wherever it is created, so in between that, you will have a good insulator path. And due to which the resistance will be infinite. So resistance between the open terminals is going to be infinite. And the last thing is that whatever the supply voltage is in a series circuit, if it is open, then across that terminal you are going to have the same voltage. So the same voltages appeared here. 40 volts is the same voltage here as supply. So that's the working in a series circuit if you see any open condition. Now next is this slide also talks about this circuit, and it tells that applied voltage VT is still present in the circuit when you have an open circuit condition and zero current is flowing. Then also your VT voltage will be present, and voltage source still has its same potential difference across its positive and the negative terminals. Now example is given that in the wall outlet, you know that you have 120 volts potential difference comes from the wall outlet, and what you do, you connect appliance to the wall outlet, and then current starts flowing. And if you touch the metal terminals when nothing else is connected, then you will receive a shock, which you should never do that. It's just for understanding that you can connect when you connect appliance to the wall outlet, it creates like a series circuit, and then current starts flowing, and then your appliance basically starts working. Now, effect of short in a series circuit. When part of a series circuit is shorted, the current flow increases. We already saw that the resistance is going to be small or zero. So when part of a series circuit is shorted, the voltage drops across the non-shorted elements, increases, and the voltage drop across the shorted component drops to 0 volts, because the resistance is 0, and if you multiply resistance, you know that V is equals to IR. So if resistance is 0, then voltage is also going to be 0, and that's why you get the 0 voltage drop across the shorted component. And on rest of the components or rest of the elements in the circuit will have increased voltage. So let's see this with multiple resistance. This is a series circuit example with multiple resistance where this portion R2 is basically shorted. So you see that this is shorted by this wire. So the voltage across this is going to be 0. Why? Because we have the 0 current. So 0 multiplied with whatever the current is flowing. Current is going to be larger because now this resistance is removed, so current is going to be larger. It's not going to be wasted in the resistance. So the voltage across this terminal is going to be 0 volts. Now when this is 0 volts, then you know that by the law of KVL, Kirchhoff voltage law, that algebraic sum of all the voltage in a circuit must be equals to 0. So this is the 40 volts, then these two, then since this is 0 volts, so these two resistance should have the voltage across this, which should be equivalent to 40 volts. Okay, so that's why the voltage across this will increase because the voltage across here is now 0 volts. So that's why you see the increased voltage here, but right now we don't know what was the actual voltage before, and that you can calculate on your own and see how much voltage rise, how much voltage has gone up when this R2 is shorted. When troubleshooting a series circuit containing 3 or more resistors, remember the component whose voltage changes in the opposite direction of the other components is the defective component. So this is the main gist of troubleshooting open or short condition in a series circuit. And in other words, we can describe this this point is that in a series circuit containing any open condition, then all the good components present in the circuit will basically receive decrease in the voltage, which will be equal to 0 volts. So I'm saying it again, when there is open in a series circuit, then the voltage across all the elements, rest of the elements will be equals to 0 volts. and there will be zero current, and all the voltage which is supplied by the supply voltage, that will appear across that open terminal. And in case of short circuit short circuit condition in a series circuit, the voltage increase we will see in the good components, or in rest of the components which are not shorted, and the component which is shorted will receive 0 volts. This line is saying the same thing. The voltage changes in the opposite direction of the other component is the defective component. And we are going to take this example. So in this example, we have supply voltage 24 volts. These are the 4 resistances. And if you see, we are seeing 0 volts here, and 0 volts here, 0 volts here, and 24 volts here. So this 24 volts is the same supply voltage. That means just by this voltage across the resistances, we can detect that this is open. So this side is open of the circuit, of the series circuit. So you can say R2 is open, because we are seeing the supply voltage across these 2 terminals. Okay, and as you know, rest of the components or rest of the resistances will receive 0 voltage. And if you want to verify what we are doing is correct, you can also follow this step. You can calculate the total resistance first, which is going to come out to be 600 ohm, because this is 150, 180, and then plus 120, 600 ohm. And then we can calculate the current flowing into the circuit. VT is our 24 volts. RT we have already calculated. So 24 volts divided by 600 ohm, that will give 40 milliamps. And then you can calculate the voltage across each resistance, and that will give you the value of the voltage when the circuit is not in the open condition. So for example, V1 is equals to I into R1, and in V1 we have 6 volts, and in V2 which is equals to I into R2, I is 40 milliamps. 40 milliamps is the same current flowing in the circuit, so this is going to be the same, only resistance will change for each voltage. So finally we got V1 is equals to 6 volts, V2 is equals to 4.8 volts, V3 as 7.2 volts, and V4 as 6 volts. So when the circuit is working normally, then these are the voltages we should get. Okay, but that's not happening here. We are getting 0 volts, 0 volts, 0 volts, and here 24 volts, which indicates that something is wrong in this particular portion of the circuit, and which means the circuit is open, because we are seeing the full voltage over here, the same as supply voltage. Now let's see troubleshooting opens and shorts in the parallel circuit. So far we have talked about the series circuit. Now we are moving to the parallel circuit. Now what will happen when the when a parallel circuit has open? So an open circuit in one branch results in no current through that particular branch. Okay. However, an open circuit in one branch has no effect on the other branches, because that's the beauty of the parallel circuit, that because they are connected in parallel, and each of the branch will receive the same voltage level. And if one of the branch is disconnected, then that is not going to affect the other branches. And that's what it is saying here. This is because the other branches are still connected to the voltage source. An open in the main line prevents current from reaching out to the any branches, which is very obvious, that if your supply voltage is disconnected, then, or the main line is disconnected, then the circuit will not have the common voltage. So let's see here. This is the case. First case is that your main line or supply line is disconnected. So no matter how many branches you connect later on, it's not going to get any voltage, because the line has been connected here in the beginning. So the voltage here is going to be 0 volts, and if it is 0 volts, then these bulbs are not going to light up. Second case, when the supply is given to the same circuit, and let's say this particular bulb has open filament, then what will happen? Or you can say that this is open circuit, this is open. Then what will happen? This particular branch will kind of removed, or you can assume it as it will not going to affect the other part of the circuit. And that's what you see here, that bulb 2 and bulb 3 are still bright because the voltage you see here is same. The voltage they are receiving is same. So and the filament is not good here, so this will be treated as your open, and rest of these two branches will receive the current, and then these two bulbs will be brightened up. So this was the effect of open in the parallel circuit. In the first one, open path was in the main line, so that's why you saw no current and no light for all the bulbs. And in the second case, open path was in the branch, and in that case, bulb for that particular branch does not light, but did not light, but the other two bulbs they operated normally. Now, shorts in the parallel circuits. A short circuit has zero resistance. We already know that from the series circuit, resulting in excessive current in the shorted branch. A shorted branch shorts the entire circuit. Okay, and current does not flow in the branches that are not shorted. They are bypassed by the short circuit path that has zero resistance. So we are going to understand this through the circuit. So let's move here. So this is your normally operated circuit, which has some voltage source here, and then resistance 1, resistance 2, and then some ammeter is attached here to measure the current flowing, and the current is basically 2 amps. And in the second case, when you have a voltage source and the same circuit, but your this G and H terminal, it is shorted. So when this is shorted, that means the resistance in this wire is 0. And if the resistance is 0, the higher current will flow. And you know the nature of the current is that it tries to follow the low resistance path. So what will happen? All the current will actually flow through this wire and return to the voltage source. And that's what it is saying here. So a shorted branch shorts the entire circuit. So this shorted branch basically shorts the entire circuit, because now current will try to basically flow through this and will avoid these two resistances. So current does not flow in the branches that are not shorted. They are bypassed by the short circuit path that has zero resistance. So this thing we learned from this circuit. And this was the parallel circuit, and we saw the short circuit condition. Now moving on to the next is the series parallel circuit, and we will see the effect of open and shorts in these circuits. So an open or shorts in one part of the circuit changes the values in the entire circuit. When troubleshooting series parallel circuits, combine the techniques used when troubleshooting the individual series circuit and the parallel circuits. So we are going to combine those techniques and use that for when you have a circuit which has series and parallel combination. So let's see this through the circuit. And so in this circuit you have a series resistance, and then you have a parallel branch also there. And then there is this switch S1, which is right now disconnected. And we are going to see the effect of this switch when it is closed and when it is open. And then we have three resistances, R1, R2, and R3, and some voltage VT of 100 volts. So let's see the effect when S1 is shorted. So when S1 is shorted, then what will happen? You know that the resistance in this particular branch is going to be 0. So the current will basically flow through this path. It will not go beyond that because this is the shortest path it will see. Okay, so that's why you see here in picture B a circuit with short between this A and B terminal. When S1 is closed, then you see that this is the path it will follow, and this R2 and R3 will basically act as a short circuit. So that's the circuit when this is S1 is shorted. And what will happen, so this is the same thing which we saw previously. So S1 is open. So when S1 is open, then the current will flow through this, and then current will flow through all these branches like normally. So total current increases from 2 amps with S1 open to 10 amps with S1 closed. So what it is saying is that it will have 2 amps when S1 is open, because when S1 is open, the current will flow through these other branches as well. But when S1 is closed, so like in this condition, you will have more current because zero resistance, so more current will flow. That's why you see in this particular circuit 2 amps, and in this particular circuit increased current which is of 10 amps. And with S1 closed, R2 and R3 will be shorted. So these two resistance will be shorted out. Now, effect of open in series parallel circuit. Now we are going to see the effect of open. So this is the series parallel combination of the circuit, and this S1 is the switch. So when S1 is closed, then the circuit current will flow through all these 3 branches like this. Okay, and when the circuit is closed, then you will have some voltage across this CD terminal. So which will be the voltage across these 2 points actually. So that will be your voltage in that case, and where V3 is 80 volts, so you are going to get the same voltage, 80 volts. And in the second case, when your CD is open, so this S2 switch is open in this case, then what will happen? There will be zero current flowing into this resistance. Okay, so there will be zero current flowing here, so that means the voltage across this also is going to be 0. So you will have some voltage across this, and that voltage is going to be equivalent to the voltage across this R2. So you understand my point. When it is closed, when the switch is closed, then the current distribution will be like this, and when S2 is open, then current will only flow like this. Okay, and there will be no current here, and that's why V3 is equals to 0. And whatever the voltage, so the voltage across this CD is going to be the same voltage which appears across this R2 resistance, which is 89 volts, and that's why you see this 89 volts. So the effect of open path in a series parallel circuit, normal circuit with S2 closed, and second one is series circuit with R1 and R2 when S2 is open. Now R3 is the open path and has no current and 0 IR voltage drop. So that's what you saw here. With S2 open, R3 is effectively removed from the circuit. So yeah, so they are talking about this resistance. So this will, you can say that effectively is removed because it has 0 volts. So even if you remove it, still the circuit will be fine. The current path will be this. So this is the effect of open in a series parallel circuit. Now let's see next. So the same circuit which you saw previously, and you see here the output voltage is across VCD is 89 volts. So with S2 open, the voltage across points C and D equals to the voltage across R2, which is 89 volts. So across R2, the voltage is 89 volts, and the same will appear here. The voltage across R3 is going to be 0. So that's all for all in series parallel combination of circuits regarding open and short condition, and that's it. Thank you so much for watching.